serverless architecture for the healthcare. So we'll be specifically focusing on the healthcare, is because that is kind of compliant-oriented domain, I would say, and it's very less talk has been done on the serverless plus healthcare combination. So we'll try to cover that in today's webinar, and hopefully next 1 hour will be like you guys will take a lot of good takeaways today after the webinar. So moving to the next slide. So basically, this bit about us. Myself, Pravin. After my doing my master's in 2007, I worked with many startups, more than around 5 years. And after that, I co-founded Mindbrowser, which is a services agency. We started in 2012, and in last 10 plus years, right, we worked with more than 100 plus customers, mostly starting from an ideation stage to the till they're helping them in getting even Series A, Series B funding, right? So we had a lot of success stories who worked with us, and good part is that I was part of their journey from starting from the day one, where we had a napkin idea on the napkin, and then I helped them in creating the architecture along with my colleagues. This is a bit about me. Kiran, over to you. Why don't we quickly brief about yourself?
Yeah, thanks, Pravin. Yeah, this is Kiran. I am having around 18 plus years of experience. I worked in actually various MNCs and startups. And my journey started with programming, Java programming, then eventually moved to architecture side in the areas, in the microservices, cloud engineering, data engineering, the enterprise architecture. So like that. Yeah. So that's what about myself. And
Okay. Thank you, Kiran. Thanks.
Yeah. Thanks.
Yeah. So today,
thank you.
So today, this is high level agenda for today's webinar. So we'll be covering a lot of topics, which is of course related to serverless, and of course these are pretty high level. There are few topics which are maybe high level, like for example multi-cloud, right? So again, there is a very less talk about multi-cloud strategies for the serverless architecture. Then even comparison with the PAAS and containers, right? So we'll be covering most of the majority of the things in the serverless along with the healthcare, right? So we'll be connecting the dots here. So let's start with the first topic, right? So why, right? So this is more often I hear that when any customer comes, right? So why we're not going with the traditional approach of, let's say, having even starting with the simple virtual machine on AWS, for example, EC2. Why can't we run the load on that, right? Or maybe for making it more complex, like say Docker containers or Kubernetes and whatnot, right? So why we're not going to why we're not architecting that way? Why serverless? So this is an important question to be answered. I believe many of people from the audience also is curious to know why we should go with the serverless. I'll hand over to Kiran. Kiran, why you think serverless is maybe a need of an hour? Maybe what your experience tells you?
Yes, Pravin. Mainly, this is the main question that everyone will be asking. Whenever they start project, why actually will be going? What is the need of serverless, and why can't we go with the traditional approaches like infrastructure as a service? So those kind of things, which was a classic way of going. Mainly, the thing is, whenever we start a project or whenever we plan the estimates for a project, so along with the development, we give almost some percentage of effort, mainly for the infrastructure provisioning and infrastructure maintenance and all that. And even it costs to the vendor and even it costs to the client. So in every aspect, actually, that infrastructure is a separate task that where we need to consider. And along with that, capacity planning is one more thing. So these are all actually incurs a lot of effort. So for that, actually, we can go with a kind of a cloud vendor where different cloud providers provide actually managed services. But again, there was in the coming slides, I'll be explaining that also. Why actually, what is the difference between managed services and why now we are telling about serverless. So when we say managed services are serverless, So that will reduce the infrastructure operational overhead, actually, where the development team is facing. So that the development team or the project team, they can focus on the important things that needs to be delivered based on the requirements, and they can just relax, and so that the cloud providers will take care of infrastructure maintenance, provisioning, and all that, actually. So this is in both terms for managed services and serverless, but there is a quite difference between these two. But still, there is actually serverless will be one edge over managed services. Like serverless, the main thing is the billing. So pay the cost for that particular bill. So that is the main thing, like where it will not charge for the idle times. So that will save a lot of cost. So that is the main thing. So with this serverless approach, we don't need to worry about creating servers. We don't need to worry about creating or installing the softwares for the runtimes like Java, Python, Node.js, right, PHP, or anything. And we don't need to worry about scaling things, like managing auto scaling things and all that. And similarly, security part, like any security patches that needs to be updated at the OS level or anything. This actually serverless architecture will take care of. The word actually serverless is confusing to everyone, that they'll think that many people still, when they come and ask me, like serverless is like there is no server, but it is not like that. Still there is an underlying server, but it is not visible to us, and that will be managed by cloud provider completely.
Yeah. That's a good point. So basically, even like if I connect back, right? So recent case study, like recent product we launched for one of the companies. So the time to market was pretty quick. So within 2.5 months, we had like first version, and that is being used by big companies like Twilio and Whitepages, and that is like having 400 QPS per kind of a queries that we are performing. That is the API product. But yeah, that reminds me, like again, like if I compare, right, with the Kubernetes approach, that will going to take a lot of time from the DevOps people for the infrastructure provisioning, right? And managing it is on a headache. So yeah, definitely a lot of advantages for sure.
Yeah, correct.
Yeah, this is, I think, it's more about architecture, right?
Yes.
Why don't you think?
Oh, yeah. So as I was telling you, that like serverless means it is not that there is no server on that, but serverless is still there is a server and everything is managed by cloud provider. So we will have an abstraction layer on top of cloud infrastructure. So where the user or the vendor who is using that cloud, so they will be using this abstraction layer, and underneath there is an infrastructure platform which is not at all, which is completely not at all visible to us. We just actually use their environment for configurations and deployments. But underlying, there is actually server. So that's why it is an abstraction layer on top of cloud infrastructure. So then another main advantage is actually developers can focus on solving critical business problems, and they can bring quicker to markets, because that the project team where they spend almost 30 to 40% of effort in setting up the infrastructure, setting up the scaling things, next setting up the security related everything, that time will get saved actually with the serverless, so that everything will be ready on the cloud. Then we just develop the code, test it, and deploy it. So that's why we can bring that to markets. And that's what actually this all again depends upon, will affect directly proportional to the agility, reduce time to market, minimal overhead of infrastructure, and all that. And even nowadays, we are seeing the digitization and digital transformation. So many people or many projects actually, they are going from legacies to modernization. So for that, for the modernization of digital transformation, the serverless computing is very useful because of these features. And basically, serverless compute, for example, if you take, it can be considered as one single entity, that is a granular computing resource, so that can process a particular business functionality. So especially in the digital transformation, when we do modernization, so many of the legacy services or the monolithic based services, they can be converted to microservices. And a microservice can be mapped to one serverless computing unit, so that where we can map a code to one deployment, so that can be run as one granular unit. And the main important thing, which I was telling in the earlier slide, like We have managed services and serverless. Managed services like PAAS, platform as service in the cloud, and serverless also. So many people will ask, actually, already we have PAAS, what serverless brings advantage? Because PAAS also, cloud provider will take care of the runtime, infrastructure, scaling, and everything. Then why serverless? So this is where the difference that comes between PAAS or managed service and serverless. So the difference is, so managed service, though you are using the you are using the system or not using system, it will charge actually. But serverless, it is not like that. So it will not charge for idle times. It is like serverless, when you use only, it will be active. When you don't use, it will be in sleep. It is as if you are putting your system in hibernate mode actually. So as you are working in laptop or something, you will be putting your hibernate mode. That is an idle. Again, actually, when again any request or any processing request comes, or any request comes from external thing, so then it will again start. So there are some limitations to that, which we are going to see that also, like where we see some cold starts or something like that, because of that causes latency and all that.
Yeah.
But that is the main difference between the managed PaaS service and the serverless service. Where, for example, I'll tell you one simple scenario. When we go to Azure, Microsoft Azure, so there is a provisioned SQL and there is serverless SQL. So in provisioned SQL, what will happen is it is actually managed service. It's a complete platform service. There also, you don't need to worry about infrastructure or OS or anything, security or patch, anything. But there the charge is per hour. I mean, both for serverless and this one, charge will be stored for storage area. But for compute, how it is charged is, compute only when the queries are getting executed only for the particular execution time. In serverless, it is charged. But in PaaS, it is not like that. Suppose it will charge for hourly bill. For example, even if you use for 15 minutes, so it will charge for that particular hour actually. So that means for 15 minutes also, if you use, it will charge for 60 minutes. So, but serverless is not like that. If you use only for 15 minutes, it will charge only for 15 minutes. So that is the main difference with serverless and this PaaS that you are bringing. So that's what actually not charge for idle time. It is as if actually it is going, your system is under sleep if there is no active action that is being undergone.
Yeah, I think even like for anyone who is already using managed services or in containers and stuff, right? So dedicated instances, I think is the right time to check it out, or what is the right way to check, right? So for I believe like under the CloudWatch monitoring, one can check how much idle resources are, right? And accordingly, they can take the decision. Okay, if we move to serverless and let's say 80% of resources are idle all the time, then I think they can save a lot of cost, right?
Yes, Pravin. That is correct.
Okay, great. Moving to next slide. I think again these are like kind of a pretty great trends that coming up for the serverless, right? I think you spoke about it in earlier webinar as well, but why don't you quickly brief them?
With serverless trends, in the coming years. So basically, nowadays actually even multi-cloud is becoming very popular. Many organizations are tending to incline for multi-cloud instead of going for a single cloud, considering very high availability and automatic dynamic disaster DR approach. So that's why they are preferring, and also even cost optimized services also. So they are preferring multi-cloud, and serverless also is becoming to the trend where it will be a single abstraction layer over a multi-cloud platform. So that is one trend that is coming on. And even containers also, currently containers mostly are managed services, but now containers are also coming in serverless platform. Already actually the trend already has been set in AWS already with, for example, if you take Fargate, Fargate actually is a serverless approach for EKS actually. Similarly in Google GCP also, there is Cloud Run actually. So that is also actually serverless where it runs containers. But the trend is going to get more in coming years. And similarly, as of now, serverless platforms are vendor locked in actually. So that means, for example, whenever we want to develop the applications, we use vendor related code also. For example, who might have experience with the Lambda. So when we write Lambda actually, so there will be Lambda related handlers that we need, right? Otherwise, that code will not get executed in Lambda. So when we integrate either Java Spring Boot with Lambda or a Python with Lambda. I mean, you'll in addition to the Spring Boot code, in addition to the REST API controllers that you develop, you'll also develop Lambda handlers also.
Yeah.
So that is becoming one nightmare actually when we want to make that as a cloud agnostic. So now actually even open sources are also emerging in serverless platforms, where actually vendor lock-ins will be eliminated with this trend actually. And similarly, edge computing in serverless, like that is emerging now, because edge computing is very popular, especially in the automation factory areas, in IoT areas. So where actually there is a lot of data that needs to be processed at the edge area, instead of bringing the massive amount of data to the cloud, which actually consumes a lot of network bandwidth and performance latency. So edge computing is becoming very popular, especially when we want to do some analytics or IoT streaming analytics and all that. So for that, actually, serverless options are becoming are coming as a trend in the edge computing areas. Similarly, even now, when we want to do end-to-end application development, either at API level or web services level or an MVC architecture-based applications, still we are not leveraging complete serverless, but the trend is coming in future. So wherever we are using serverless, like kind of event-driven mechanisms or processing systems at the analytics layer. So that is serverless and even data storage developed NoSQL, like horizontal scalable. So serverless is actually limited to that scope as of now, 60 to 70% of the projects. But in coming days, actually, even the complete end-to-end web applications or APIs, web services, they are going to actually move to serverless. That trend also will be coming. Similarly, in data engineering analytics, as I was telling you. So that also, for example, already, if you take in AWS, we have Glue, which is actually serverless Spark that is processing the data. So already that has come, but more trends, more type of services will be coming in the coming years. Similarly, especially for healthcare, digitalization in maintaining HIPAA and regulatory compliances, the services. So that type of trend, for example, in healthcare, we can do data analytics, processing for healthcare records, clinical trials. Similarly, web services, web applications for healthcare-based applications, patient record information. So all these needs data analytics. Similarly, API-based microservices. So and in healthcare especially, we need to follow HIPAA and regulatory compliances. So serverless trend is coming as an end-to-end chain from, if you take in analytics from ingestion to the reporting, and if you take APIs from the UI to the backend layer. So end-to-end modernization trend is coming in healthcare for serverless. Yeah, these are the few server trends and many more. But so we listed actually some important trends. So, but many more are coming in the coming years.
Right. Yeah.
Yeah. So basically, if you go in depth bit, some like as a kind of a technical design for serverless. So what can be fit in serverless core technology components? So when we design an application, so the first and foremost is API gateway. Next is function as a service and a backend as a service. So with this, actually, yes, definitely 100%. I can tell that we can develop actually a web-based application, or we can develop an API, a RESTful web service, or we can develop actually an analytics with ingestion-based application. So the first and foremost, if it's an API gateway, this is actually we can call it as an interface between the client and the function as a service. And this actually handles all the client requests that are coming, and then it will have a capability for security, next rate limiting called throttling, caching, everything. And so that the backend, the function as a service can work like a microservice, or it can work like a kind of a data processing unit actually. So when we say in a typical microservice architecture, function as a service is nothing but a microservice. It's a granular service that computes or that processes the data. So the request that is coming from API gateway will be flown to the function as a service, which process the data. And from there, it goes to the backend as a service. And backend as a service, definitely it should be a persistent store, like a data store, which is again completely scalable. So with this kind of core technology components, we can build definitely one web-based application. We can build even an MVC kind of an application. We can build a kind of a RESTful API service.
Yeah, and within this also, I believe like database, the backend as a service, right, where the database operations will going to happen. I think database can be a serverless as well, right? So
yes, yeah, database is also serverless. Correct.
Yeah.
So yeah.
So I think let's maybe why don't we focus on one kind of use cases in healthcare, right? So today, like we're talking about serverless in healthcare. It will be great, like if we can give some more idea to audience about the different use cases.
Yeah. So especially in healthcare, even IoT is used majorly, where actually IoT devices will be sending a lot of telemetry or streaming data. And we can leverage serverless computing to process the data, because especially serverless computing is more used in unpredictable workloads actually. Actually, for predictable workloads, definitely we go with the provisioned thing. But the main advantage that we get with serverless computing is unpredictable workloads. So for this hour, we get this much amount of load, but there is no guarantee that the next hour we get this much amount of load actually. So that's why actually serverless is preferred in the scenarios, and especially IoT devices in the healthcare will be sending a lot of data for data processing, for which we can use serverless computing, where actually and it can be even leveraged at the edge computing area, or it can be leveraged at the cloud computing area, and even we can store that in the database as Pravin was mentioning. Like even database also can be considered as serverless, where actually only the storage there will be pricing charged, but database, how the pricing charge for serverless will be, like only depends upon the query execution. Only for that particular time, only the for the bill will be charged for the database areas. So in that way, IoT devices and streaming data can be processed in healthcare, and similarly, health record of patients, clinical trail data processing also can be leveraged with serverless computing. And even actually, I'll tell you one use case that we have done 4 years back for one of the big. It is a life sciences thing for one pharma industry, where we use serverless computing to do some kind of machine learning models to predict actually some detection of some diseases actually. In a particular patient's history record. So that has been done by clinical trials data, similarly health record of patients, historical data. And so that data was processed through a lambda layer for event-driven processing. And similarly, we have used kind of SageMaker, which is actually Amazon SageMaker. There is a kind of ML service actually. That is also serverless. And we store the data in DynamoDB, and we leverage the DynamoDB streams to actually trigger the Lambda. So that kind of thing we have used. So this is one major pharma industry actually. And that is one thing. And similarly, in healthcare, even video conferencing between the patients and doctors and doctors and pharmacists. So these will be going predominantly. And similarly, remote monitoring of healthcare integrated. So these can be actually, this kind of system can be built with serverless computing that brings a lot of benefits and reduced operational cost. Because when we go with provision capacity for this, we can't determine the workload of this, and the provision capacity unnecessarily charges for the ID levels also. So serverless computing can actually charge only for the particular hours where the process has been executed. So these type of things we can actually leverage serverless computing.
Great. I think we can take one question. So this interesting question has been asked by Amrik. So is there any relationship with analytics of the serverless architecture? For example, using relational versus NoSQL?
Yeah. So basically, if we see mostly serverless actually databases are NoSQL, but in Azure, if you take Microsoft, there is actually SQL Azure SQL, which is an RDBMS that has become serverless.
Yeah.
Similarly, AWS Redshift has been to serverless, and RDS proxy, though it is not a database, it is maintained for connection pooling. It is a serverless. So mainly the choice actually depends upon that if you want to use for data analytics like SQL or NoSQL. So generally for data analytics, where there are more kind of dynamic schema capabilities and also horizontally scalable capabilities, NoSQL is preferred when compared to RDBMS. So the choice that depends upon our requirement. Either we have to go with NoSQL or RDBMS. That all depends upon our design choice, whether we have to put NoSQL or SQL based on the conditions. For example, I'll be telling you one scenario where recently we got, in analytics, we got a concept called ETL, zero ETL actually. That is called zero ETL. What is zero ETL is? So we don't actually no need to do extraction, transformation, loading to create the pipelines. Actually, we create pipelines and do all these actually ETL. If you see in Amazon, there is an actually there was actually recently one service has come that is Redshift serverless. Actually, Redshift itself is actually warehouse, which is actually RDBMS. It is actually completely relational data. But Redshift serverless is also relational data, but it completely runs on serverless. That means it will charge only for the, it will be idle when the queries are not getting executed. So with Redshift serverless, what we can do is we can even use federated queries to connect to the RDS and all that and do the analytics actually. So it is not like that it all depends upon the choice that we do the design. Either we have to go with RDBMS or NoSQL. Once we decide upon that, we have choices to use serverless either in NoSQL or in RDBMS.
Yeah. Okay. So I think these are a few other examples of the use cases in different domains apart from the healthcare. So basically, even we had a few great customers in the live video broadcasting, right? As you mentioned, IoT, right? Non-healthcare customers also, like there are a lot of IoT devices data that is coming, and we are using a lot of serverless framework. For example, on AWS, I think you have rightly mentioned about one of the use cases where we are using Redshift along with the Lambda triggers, right? So can you tell like more about the couple of other use cases, maybe more on data engineering and analytics, which you covered right away. But again, the event-based automations, right? Maybe why don't you put more light on that?
Yeah, sure. For example, when we consider actually the serverless-based analytics in AWS, earlier we used to go with the kind of Spark-based transformations or Hadoop-based transformations, either running in EMR or Databricks. With the Glue, actually, AWS Glue is a serverless a Spark computing area. So it will only charge for the compute area, compute power, only for the job that is running. So Glue is one of the famous serverless computing in AWS. So similarly, Redshift serverless, which has come from Redshift. Earlier, we used to bring the data either from S3 and store in Redshift. We create some pipelines, and there in Redshift that used to be like a warehouse, data warehouse, where we do some aggregations and do the analytics on the data actually by running some queries. But with Redshift serverless, even with Redshift in classic Redshift also this feature has come, but Redshift serverless is more powerful. Where in Redshift serverless we need not bring the data to Redshift. Still, the data can be there in Aurora database or RDS, where it can still from Redshift serverless we can query the data that is there in RDS and do the analytics. So this will actually eliminate or reduce the latency in bringing the data from RDS to Redshift. So we don't need to create the pipelines and all that. So this type of approach is called federated query approach. So from Redshift only, we can actually query the data on Aurora or RDS, and we don't need to bring the data to. So these type of analytics features are, which is actually becoming more and more dynamic. Similarly, even EMR is one of the managed cluster provided by AWS. It is not a serverless, but it is a managed cluster. But from managed service, we can connect to Redshift serverless directly without writing any connectors or anything. So it has an inbuilt connectors. So those type of data analytics features have come. And similarly, in one of the very popular thing we do in this kind of video broadcasting or image analytics, compression of the image is very popular service actually, because more the images, to reduce the storage space, we compress the image and store it.
Yeah, even the elastic transcoder, right? I think the video transcoder.
Correct. Yeah, that is also one service. And this type of image decompressions, next broadcasting client, and similarly encoding the video data, like as you are telling, like transcoding and all that. So these are all actually various serverless options that brings many advantages to us, which reduces the operational overhead and reduces the latency and increase the performance.
Correct. Okay, great. Yeah, let's take one question. One of the user is asking that whether it's a best practice to break the heavy workloads using the queuing services, like event-driven mechanism, and then using the serverless functions to like divide the workload, right? But again, one of the cons that is being mostly talked in serverless computing is that limited execution time, right?
Yeah.
So whether we should use the queuing service, or I believe there is one more way to do like kind of a step functions, if I remember correctly. So maybe
Yes, correct. Yeah, so this is one good question actually. Anyhow, that is there in our next slide. That is one of the limitations. Till now we have studied about advantages, but still we haven't come to limitations. But yeah, so in serverless actually, especially when we go for lambdas or these cloud functions in Azure, there is actually like kind of request execution time limit actually. For Lambda, it is not more than 15 minutes actually. And for serverless, generally Lambdas we prefer only for online processing, but not for batch processing or anything. But still, if you want to go with this kind of batch processing, I suggest why to go for Lambda. Still, if you want to go with serverless, use Fargate actually. Fargate is actually a serverless Kubernetes service. So even actually it can take more workload and it can even process the data, just like how a EKS process the data, and even it can run in batches. Of course, there is a limitation in serverless Fargate that it is only used for stateless applications, but not for stateful applications, where state is not maintained. We cannot maintain any session state. It is completely the state is maintained at the client end. But still serverless, we cannot completely tell that but just by seeing lambdas, we cannot tell that serverless is only used for less request processing times. Fargate is there actually. Fargate it will work like normal Kubernetes. It is a serverless company.
Yeah.
Similarly, Cloud Run is there in Google Cloud. Okay, there is that. So that is the reason. If you want to go with a serverless based approach completely, and you want to use batch workloads, you can leverage serverless. If still you want to, you can leverage Fargate. But still, if you want to go with lambdas, yes. In lambdas, the lambda processing time is not more than 15 minutes. So what you have to do is either you have to go with step functions that takes multiple lambdas. Each step function is one task in a workflow. You can create a workflow with step functions, and you can divide the tasks between multiple lambdas so that each lambda will not take more than 15 minutes. Process the data in the batches of queues. You can go in that model. Or there is one more model. Actually, it is a raw approach which we can do that also. Even we tried that. For example, in Lambda only we will write a code like listener code when it is actually reaching 15 minutes of time and still the process is running. So this listener will will come to know that still the Lambda process is running, but definitely it will time out after 15 minutes. So before 15 minutes, Lambda will trigger a metadata. So that once 15 minutes time is reached, that metadata will trigger again another Lambda execution automatically. So though the state is not maintained, it's completely with stateless data.
Right.
Actually. And we should use checkpoint. Yeah, there's a bit complex process. Still, actually, if we are actually good programming experts, we can achieve this kind of thing. But one thing I'll tell you is, with serverless, you can still use Fargate in AWS or in GCP Cloud Run. You can still use, and those kind of capabilities are there even with the batch workloads.
Right. Yeah. Yeah. I think these are some of the topics. I think there are some questions around this, and many of them get answered. Will get answered after this. We speak more about the advantages and the limitations, right? So as you rightly pointed out, few of the limitations like cold start. Again, AWS is doing as far as AWS is concerned, right? So they are doing a lot of uh, work around this to make sure that the cold start and the time gets reduced. Recently, I think in the last reInvent, like last month itself, they have launched the Snap Start, if I'm not wrong, right?
Correct.
Yeah, I think even we tried in one of the projects, and that has given a kind of a very bright results, because that is not only saving a lot of milliseconds for each request, but also saving a cost in turn, right? Because the Lambda time is directly proportional to the cost. So this is kind of one of the limitations they have recently reduced. But again, there are some more. Why don't you speak about them?
Yeah, so advantages we have seen till now. So when we come to the limitations, yes, Pravin was mentioning, yes, cold start is one thing. As I was telling, it is just like serverless is whenever the process is running, it is active, and whenever the process is not running, it goes in sleep mode actually. And again, when suppose when any request it has to process, new request it has to process, again it will bootstrap. So bootstrapping in such a way, again it will start its complete process. It will load the program in its memory and start execution. So loading the program in memory and starting the execution will take some time. That is what we call bootstrapping actually. So that because of that bootstrapping, the time taken for bootstrapping is nothing but the cold start actually. And as Pravin was mentioning earlier, like recently, last month, Lambda AWS actually is doing some, bringing some enhancements in Lambda, that too with the Java runtime as of now, not with other runtimes, with the Java runtime. So it is doing like kind of, so whenever Lambda is running, it will preserve the snapshot in some persistent store, and it will use that persistent store in the next bootstrap. It will not again bootstrap. It will take that snapshot and again start its function. And that snapshot will be preserved for 14 days. After 14 days, that will get deleted. So that is what actually, that too they have just put for, Java runtime. And
I think
similarly,
even they have similar thing called concurrent. I think concurrency, right? I mean, concurrent execution. They are also having,
correct.
right?
Yeah.
So
yes.
But that is again costly a bit.
Yeah, that is actually provisioned is there, where actually provisioned is there during the concurrency, but that is very costly. So that is charged for unnecessarily for, that will not actually again suffice for the serverless. When we go for provision means again it becomes a managed. So it is as if that will not actually suffice the actual serverless definition.
Exactly. And even the Snap Start, what they have launched recently, I think the enhancement they did, right? Even that has a limitation in terms of the, if you're having any network drive, right? The NFS or something, any file system. So it will not support that. So that is one of the disadvantages we
correct.
face.
Yeah, correct. And then one of the another limitation of serverless is multi-tenancy. Like when we say multi-tenancy, especially now, suppose it's a few competitor businesses, so they will be using serverless, and because serverless is completely managed by the cloud provider, so and definitely the competitor applications, two competitors, for example, let us take, and they deploy in the serverless. So it is not guaranteed that they will be running in dedicated infrastructure because it is completely managed by cloud. And there might be a possibility that the scaling, the high availability of both competitor services are managed by the same cloud provider. And it will be a concern like the data also might be shared, but definitely the cloud providers have a lot of restrictions in sharing the data and anything. But since it's actually a shared model, serverless, definitely the competitors will face a stiff competition, like in terms of scalability, in terms of security. That is one of the limitation. But again, it is a cloud provider who has a strong isolation in terms of security and all that. From the business perspective, this might be a kind of limitation. And vendor lock-in, as I was telling in the earlier slide, like now as actually serverless code that we write has actually tight integration with vendor lock-in. But how we can, there is a limitation. I mean, there's a mitigation to reduce this limitation. Like we have to follow proper coding standards and architectural best practices. So for example, I'll take a simple scenario. Whenever we integrate Lambda with Spring Boot. So Spring Boot, we are writing one RESTful web service or REST API. So what we do is we combine the code. With the Lambda related functions and the business logic. That gets tightly coupled. So we need to write proper design patterns to loosely couple the Lambda code with the business logic, so that the business logic can be separately tested and it can be deployed to any environment, any service, so that the Lambda handler may not be combined with the business logic. So we can write proper adapters. Yeah. Similarly, execution time limitations, I was telling you, it is not for all serverless services, especially for event-driven mechanisms like Lambda, those kind of things. But still, like Fargate and all, there is no execution time. And another limitation is there is no access to underlying infrastructure in serverless. Like suppose if you get any kind of infrastructure issue or anything, we cannot actually debug at the server level, just like how we debug at virtual machine level or EC2 instance level at the infrastructure as service. Like that, we cannot debug with the serverless. So that is troubleshooting becomes issue. Again, we need to raise a support ticket to cloud provider and get these issues up. So these are some kind of limitations. Yeah. And the specific advantage in healthcare are these things like, as we were discussing, like especially unpredictable fluctuation of workloads, healthcare, serverless is being used, similar to IoT data processing and HIPAA compliant services. There are many serverless related assessment part which are managed at the cloud level.
Yeah. I think another one of the limitation, or maybe like you can tell more on that. So when it comes to microservices, right? So thinking about Kubernetes or whatnot, so we can easily have inter-microservice communication, right? Through Istio or any other service thing, service gateway. But what about the Lambda? Or let's say taking example of AWS Lambda again, right? So how exactly you are looking at calling one Lambda from another? Is that like happens over the same private network, or it is how exactly it works behind the scenes?
Yeah. So whenever actually, that's what. Whenever calling one. So your question, if I understand correctly, so calling one Lambda with another Lambda, right?
Yeah. So is that like kind of you're expecting some kind of a latency in that, because these are Lambdas are actually not tightly coupled with each other, right? They are running in isolation. Yeah.
Correct. Yeah, that's what. So here Lambda, especially in the same network, for example. So network will not have any latency. It is only whenever the request that is coming to Lambda. So that will first time it will incur the cold start latency, and rather than and once it processes, actually it will be faster. And similarly, especially many people will tell that the Node.js and Python they are very faster in Lambdas rather than Java and C# code. Yeah, actually Java and C#, I mean, mainly they will be having latency in the first time start, like cold start, but once they're running, actually they are more faster when compared to Node.js.
Node.js, yeah, right. Okay, so
Yeah,
I think this is mostly like most widely asked question because the compliance, right? When it comes to healthcare, the HIPAA plays an important role.
correct.
So for whether it's serverless or non-serverless environment, how exactly the HIPAA compliance is achieved, right? So specifically speaking about the serverless, I think this table, maybe why don't you quickly go through it because we are short of time.
Yeah,
So let's go through quickly.
Basically, yeah. So HIPAA compliance generally we consider the mainly all the security aspects like data level, transport level securities, and access controls, which are authentications, authorizations. So firewall security groups, VPN connections.
Mm-hmm.
And so when we leverage serverless computing and or serverless storage, so these can be the boundaries for those areas where, for example, a Lambda can be deployed in a VPC, in a private subnet with proper security groups and can be exposed as a functional URL with HTTPS that provides a transport level security. Similarly, DynamoDB that can be protected from a VPC endpoint where only unauthorized or external access can be restricted to DynamoDB kind of things. So like that, this is for AWS. If you go for like Google Cloud, we can have a kind of cloud run that can be set up in a virtual. Similarly, in Azure, we can go for Azure SQL serverless. So that can be exposed or connected through only through VPN endpoint. So those kind of things can be created with the firewall boundaries. Similarly, audit checks and trails and secure logging and monitoring, system activity logs that can be integrated with the monitoring tools like CloudWatch or Stackdriver in Google Cloud. And the incident management, every incident management at the security level. So that will be tracked with the audit trails. Similarly, DR mechanisms that prevent system failures and backups and restores that prevent data losses. So all these can be clubbed with the serverless and make a HIPAA compliant serverless architecture.
Awesome. Great.
Yeah. So yeah, these are the building blocks like in serverless, mainly the cloud service provider responsibility for compute storage, security scaling. And with that, we can leverage event-driven computation that can even bring reduced time to market. And once it is quickly brought to the market, so product innovation group can start working on that with a lot of research capabilities. So serverless brings product innovation very quickly and brings new things to the market very quickly.
Right. And when it comes to cloud provider, right, so it's a shared responsibility model for the HIPAA compliance, right? So
Correct. Yeah.
it has to be like, of course, they do side business associate agreements, but again, there are some aspects that engineering team has to take care when it comes to compliance.
Correct.
For example, masking in the logging, right? So we can't log the PHI data, right? So one has to mask.
Correct. Yeah. Yeah, so this is actually a kind of monolithic to microservice to function as a service. Earlier, we used to have monolithic that will be split to microservices. And say a monolithic with 10 modules can be split to 20 microservices. And again, each microservice can also be split into separate serverless, which is a function as a service. So from when we navigate from left to right, the granularity of the service at the lowest level is getting increased. And the more the granular, the more the service is independent and the more it is following single responsibility principle. And completely they are on each serverless, which is a functional service, they can be event driven or which can be triggered through a push notification or a pull notification. And even each function as a service can be scaled independently on their own. So that is the architecture that we are bringing this kind of. And these are different.
The efficiencies, the metrics, right? I think one of the question is related to this. So yeah, let's put few minutes here.
Sure. Yeah. So these are different metrics like what are the measures that we consider with serverless, right? So what is the percentage of reduced operational cost when you are using without serverless and when you are using with serverless? Next, what is the percentage of auto scaling with the demand? What is the percentage of developer efficiency? Next, engineering lead time reduction in hours per month. So how much time got saved? Similarly, percentage of availability per month. So without using serverless and with serverless. So you will be definitely there will be variation in your RTO and high availability values. Next, throughput values and latency measured in seconds. Next, percentage of security incidents per month. So with serverless and without serverless, so we can create a comparison report between these metrics, and definitely we can see with some percentage ups and downs. We can see some variation between the architecture that we bring with serverless and without serverless by evaluating these metrics.
Great.
Yeah, so these are some, whenever we want to go with AWS, so what are the different serverless, kind of difference architecture, especially in the application integration layer, compute layer, and data store layer. Explaining each and every component will take a lot of time, but I can explain in high level detail. So the left side, like event bridge, step functions, SQS, SNS, API gateway. So they are used mainly for integration layer, like event bridge, where it triggers push notifications to multiple target systems. Similar step functions that will work like a workflow, which can trigger multiple Lambda functions. And similarly, compute layer Lambda is one of the very popular event-driven mechanism, as Fargate is like serverless Kubernetes service, Glue is serverless Spark, Athena is actually serverless interactive query service. And in data source also we have S3, which stores like no object file store, EFS which is actually distributed file storage at the network level, DynamoDB, NoSQL data store, RDS proxy for RDS connection pooling, and Aurora serverless, Redshift serverless, Neptune serverless. These are the serverless versions of the popular databases for Aurora, Redshift data warehouse, and Neptune is GraphQL actually. Okay, it's a GraphDB. It's a GraphDB, not GraphQL, GraphDB. So that is actually
right. No, RDS proxy actually, many might not be aware of it, right? Basically, whenever we are doing any database operation, the establishment of connection is kind of a heavy operation, right? And it can consume a lot of latency. So for in case of AWS, right, AWS Lambda, which are connecting to, assuming it is connecting to RDS, I think one should use RDS proxy to speed up their database latencies, because that is kind of as I mentioned, that is a very heavy operation. It takes few milliseconds to establish a connection and then fire a query. I think I'll quickly move from this slide, because these are the just kind of competitive, right? So
GCPs and Azure also we have.
Exactly. But I think when it comes to serverless, AWS is kind of a larger player, right? Comparatively, the services they offer, the different services.
In GCP also there is one popular serverless Kubernetes service, which is called Cloud Function. Cloud Function is the compute layer. Actually, that is main advantage of Cloud Function is it uses Knative actually, which is cloud agnostic actually. Knative is it is not tightly coupled to any cloud service. So it uses Knative Kubernetes engine, and it is actually easily managed or cloud agnostic across any cloud platform. That is one advantage it is bringing. And BigQuery is one popular tool in GCP for data analytics.
Yeah, the Firebase function runs behind the Google Cloud Functions only, right? So
correct. Firebase is one data store. And
so this is more on the Azure side. But let's one of the question was related to multi-cloud, right? So let's spend a couple of minutes here.
So multi-cloud actually, this is one reference architecture that. But it is your choice that here we have put like lambdas. If you want to go with kind of cloud functions or Fargate also, we can go with it. But this is a general idea how actually we can bring requests that are coming from outside external systems to the various cloud providers. Like any request can travel, and again it is actually multi-region based architecture. With high availability, where we can have a router that distributes the traffic between multiple clouds. Say for example, we are having 3 clouds like AWS, Azure, and GCP. So 33% of traffic can go to Azure, 33% of traffic can come to AWS, 33%. I mean, uniformly distributed we can go some. I mean, it is an ideal situation, but in practical situations, this uniform distribution might not come in real-time scenarios. Like if you see the left-hand side, which is Azure, that goes in API management, and front door is like kind of a DNS and GSLB, like GS Global Service Load Balancer, and API management like in a kind of API gateway that can trigger Azure functions. And here we are taking for an e-commerce based application where we have orders and products, and these are deployed at across Lambdas in AWS, Azure functions in Azure, and cloud functions in GCP. And again, we have a persistent store that is serverless with Cosmos DB in Azure, Event Hub for messaging systems. Similarly, here we have Amazon SQS for queuing messaging system, Aurora serverless for data store. And in GCP, we have BigQuery and PubSub for messaging system. So yeah, with this kind of architecture, we can develop a multi-cloud e-commerce based application with high availability and high DR capability mechanism. Yeah. So I think Pravin, you are in mute actually.
Sorry. Yeah, sorry. So we need quick help from you guys. We'll get a survey link, and it will just take a couple of minutes from your time. This kind of original survey research we are doing in healthcare technology for 2023. We haven't found much of the data online, so we thought we should do our own research here. So we need some help from you guys, and of course we'll publish the results once they are ready. Thanks in advance. Yeah, so let's do a quick comparison with PAAS and containers, right? So Kiran, let's maybe we can speak for a minute here.
Yeah. Basically, as I was telling, even PAAS and serverless, both cloud provider will take care of the runtime, servers, everything. But mainly thing in PAAS, it is not designed for every request to bring infrastructure up and down. So once you provision PAAS service, it will be there, and the charge will be there even for idle time also. But in serverless, as I was telling, like serverless only will be charged for the processing time, and in idle time it will not be charged. That is the main advantage, and it brings the infrastructure up and down. Because of that, we have latency issues like cold starts and all that during the bootstrapping. And between containers and serverless, mainly containers for request-driven components, and scaling is not same level control as serverless, with an exception of Kubernetes. We have horizontal pod scaling that scales based on load system. But in serverless, scaling is completely transparent and completely managed by cloud provider. And in the coming trends, serverless and containers are going to get combined, and we'll be seeing containers with serverless in coming projects actually in coming years.
Right. And one of the advantages, I was speaking with one of the customer last week. So the SLA part, right? So when any product company or enterprise product is signing a contract with the other companies, so they need kind of a 99.99 SLA, right? And achieving that with our own team, of course, it can be achieved, but it will take some kind of efforts. So with serverless, AWS Lambda itself, for example, giving 99.95 SLA on their own, right? So that is another kind of advantage.
Yes,
so definitely can take a lot of overheads.
Yeah. So there was one more question actually, like for example, serverless. What are the trade-offs between the serverless and server? Without serverless, basically, trade-offs means like we have seen the pros of serverless, like the charge per only the execution time. But serverless is not recommended for stateful applications. So, for example, let us take like even if you go to Fargate or even if you want to go for cloud function, they are only maintained. You cannot maintain any state at the serverless thing. So that means you cannot attach a kind of an EBS volume or an EFS volume or the serverless state. The only thing is your application code has to write explicitly the state to some kind of S3 or data store or somewhere. But in serverless, that is one limitation. You cannot maintain the state at the server native level. But without serverless, like EKS or Google Kubernetes engine, you can maintain the state. You can still save the state at the EBS level or the EFS level, where you can maintain it at the disk volume, but you cannot maintain that at the serverless. So that's why serverless is not recommended for stateful applications. It is only for stateless applications.
Yeah.
And so these are the securities that we bring, like access to authenticated users, authorizations, vulnerability scanning. That is one of the main for especially in healthcare to analyze for HIPAA complaints reports and HIPAA complaints assessments. Similar runtime protections to detect any malicious imports and anomalies, and network security for firewall implementations and all that.
Yeah. Again, like monitoring plays an important role, right, for whether it's serverless or not. So yeah.
So basically, we need to see the observability. I mean, track the observability and also the trails. So the popular monitoring tools like CloudWatch, Lumigo, Stackdriver, Ipsagon, AWS X-Ray, Tundra, these are all serverless things that are useful, especially in resource monitoring, metrics monitoring, and log monitoring and all that. And so basically, the challenge that we see is it is difficult to estimate infrastructure costs. Similarly, challenging process in monitoring for servers as the only way to access server still the function is called. Similarly, vulnerabilities. There is no standby operations. Infrastructure is vulnerability to cold hits. And basically, there is no lack of, there is a lack of serverless observability tools dedicated for debugging distributed systems. But that option is there without serverless. But in serverless, especially in the observability area, there is no tool that is dedicated for debugging in-depth of distributed system at the core level.
Right. So it's more like a robust logging is needed, right, in order to find out the root cause. Yeah.
Yes.
So you spoke about the cost and stuff.
This is what actually, correct. This is pay as you use, and there is no upfront cost in serverless. That is a main advantage.
Correct. So again, in case of healthcare, right? So of course there are a lot of compliance needs are there. So at every stage of the product, right, whether at the code level or at the infrastructure level, at the network level, we need to make sure that things are followed as per the compliance. So there are different tools that, of course, there are hundreds of tools available in the market, but these are the top tools that we also use in the Mind browser. For example, the Rancher, which is a SUSE product, it's open source. And again, it's a container management platform. It's quite useful for the multi-cloud strategy of any company, right? So you can easily manage multiple clusters for the single product on the different clouds, and it has a lot of great features to use. Right? For example, Istio also they have built in Istio. Then they have like monitoring inbuilt. They have even the CD part, right? So a lot of good tools, the good features that this tool provides. Apart from we have some other tools mentioned. Jenkins, Crawler is another open source tool for infra scanning. It is mostly used by AWS. So it provides a good report, which kind of following the CI's guidelines. Then there are some SCA tools, OWASP, dependency track, dependency check, which is also part of the CI/CD pipeline, which provides a SBOM report, which is again used by many products. So even the government agencies are asking for such kind of SBOM report for their product, right? So that provides a good analysis of the security issues if there are any. Then stats, these are static analysis tool. Dynamic analysis are another not much spoken area, but this is also widely used. New Vector is another tool from SUSE, which is again for zero trust security in the enterprise environment. So they also provides a lot of insights for the container security and stuff. So they provide a lot of ways to scan containers real time as well as when actually the images are built. So yeah, these are kind of a high level idea about the tools that most widely used in the not only in healthcare but in other applications also. But considering the compliance needs, healthcare products are mostly using in their journey.